I'm good with this, I think. Okay, so I'm here to talk about a new tool that we created. We just open sourced a couple months ago. Like my introduction said, I'm Tom Krouper. Work at GitHub. Been there about 10 months now. I work with a team of 3 other database infrastructure engineers, DBAs, whatever you want to call us. Yeah, so let's see. Let's go ahead and get into it. GitHub, as far as storage goes, it has kind of 2 main things. The first one being Git, which is the major amount of our storage. In addition to that, we also have Redis and Elasticsearch, but for most of our metadata, we use MySQL. We store users and notifications, pull requests, reactions, you name it. And for that, we need to have a high performance database that gives us information quickly, like everybody does. And so MySQL is the tool that works for us right now, and that's what we're using. However, with relational databases, you have to add columns, alter your tables. And we were running into some issues where when we were doing these alters, we would actually use a PT online schema change, which I'll talk about in a little bit, to make these changes to the table, and we were having trouble. So basically, with what you do with PT online schema changes, you're writing two tables at once: the original table and then the modified table, and we would run into issues where the write throughput on the databases was just so heavy that the databases couldn't keep up. Replication would get far behind, things like that. In addition, we actually had one table that was just basically we couldn't do because it actually crashed GitHub twice. And so we decided that, okay, we need to try to figure out what we can do, because there were also other tables that would could only be changed on the weekends or late at night and things like that. So we had a team meeting back in February, and we're like, well, what can we do? And we said, well, one of the big problems with the migration is that we are writing twice, and there's no way to stop that if things start going awry. And we're like, well, why can't we just cut that out, essentially? And we said, now there's really not a whole lot we can do about that. And we went to lunch. We said, maybe we can do it. And then in the afternoon, we started writing down, okay, what's good and what's bad, and what can we do about that? So I'm going to kind of go through kind of all the different processes that different ways to alter tables in MySQL, and how we ultimately came up with Ghost. So the most common one and the most straightforward one would be an alter table, which you do with any relational database. The problem with that, with MySQL, is there's only a few operations that allow you to do that online. So in many cases, you end up with your table locked. There's nothing you can do with the table anymore. You want to write to that table, well, you're out of luck. There's no good. That's no good. And that leads to replication issues, and I'll show that here in a second. So back in 2009, someone came up with this idea. It's like, well, how about not really doing an alter table live, but instead take that table, make a copy of it, do the alter on the empty table, and then copy all the data over there. Then once all the data is copied over, flip the switch, and everything's grand. So the Oak Online alter table was the first thing that came out. It was used for a little while by some people, and then shortly after that, Percona said, hey, we can make that tool better. And Facebook said, you know what, this tool doesn't quite work for us, so we're going to make our own. And then later on, LHM was a tool that was written specifically for Ruby on Rails. So I'm going to go through basically the process of the alter table and why it's kind of dangerous. With MySQL, you have a pretty typical replication setup. You have one master and 4 replicas here. When you do the alter table, you end up locking that table, like I said. At this point, your application has no hope. It's locked up. There's nothing you can do with it. If it's a large table, it could be locked for hours. You don't really want to do that, so it's kind of bad. But let's say you did the alter table and you're kind of past the point of no return, you let it go. So at this point, you have the master is done. It's happy, it's taking writes again. But with replication in MySQL, you end up in a situation where now all the replicas are doing the same alter. And not only that, replication is single-threaded, which means that these particular boxes are stale now. So if your application is reading all of this reading from the replicas, you've got stale data everywhere. What's worse is one of the servers might finish sooner. Well, now it's far behind and it's catching up, but it's giving you different data than the other one. So if your application looks at the first replica and gets some data, one bit of data, and then looks at the second one, the next time it's going to get something different. So you end up in a situation where you have all of these problems. So now the second database here is caught up and it's happy. Now the next two, they're far behind. So now you're getting three different bits of information when you're querying the replicas. So ultimately, everything catches up. You're happy. You say, okay, never doing that again. Let's try something else. So basically, what we came up with, or what people previous to us came up with, was let's use triggers to help us out. And so basically, what came along is PTR Online Schema Change is the one I'm most familiar with, so I'm going to talk about that one. The Oak Online and the LHM are very similar. Basically, what it does is it takes a copy of the table and then does the alter on it. Well, this table is empty, so that alter table is going to be quick, and so your situation where you have this, it's going to flip through really quick. Then it creates triggers on the main table to go to the new table, and so it all kind of runs through from there. Yes, okay, yeah. So here's a great picture of what's going on. And so basically, the user here is inserting, updating, deleting the original table. The triggers are insert, updating, deleting. Technically, for MySQL, it's actually doing a replace instead of an insert, or a replace instead of an update. But essentially, there's for every insert, every update, every delete, there's going to be a copy made to this new table. For Facebook's online schema change, they did something slightly different. They said, well, instead of writing directly to that new table, we'll put this all into a change log table that allows us to basically synchronize this in a slightly different way that worked out better for them. And so, excuse me, that's kind of where that one went. So both similar processes, slightly different look. So this worked out for the most part for us and for many other companies, and many other companies are still using it. Basically, you end up with a situation where you're not losing, are not stuck with your table locked for the entire time. Basically, what's happening is you are writing twice, but replication can be monitored, so you're not going to have to worry about replication getting behind, because these tools actually have monitoring on the replication. The cutover is pretty instantaneous because all you're doing is a rename table. You're renaming the original table to something old, renaming the new table to the original table name, and it's fairly instantaneous. It's very quick. And I say no locking, but the locking, you have to lock to rename the table. It's pretty minimal though, so it's pretty fast. However, there are some disadvantages of this, and we kind of ran into these at GitHub, and so we decided to look into something new. The first one is that it's a stored routines. Basically, every time that table gets written to, it has to interpret what the trigger was doing, what it needs to do, and then write over to the other table. Well, you're doubling the writes. You're going to increase locks and mutexes. You're going to have some problems. Now, like I mentioned before, if replication gets behind, the actual copy slows down or stops. And what that that's great and all, except for you have a trigger still, and that trigger is still writing to the second table. So you're still doing the double writes. So you can still end up in a situation where things are not going to be performing very well. And the other thing is it's hard to test to make sure that you have, to verify that the alter table that you're going to do is going to perform the way that you want. So, ta-da, we created Ghost. And this is, it was originally gh-ost for GitHub online schema change, but we wanted to have a cool logo, so we had to change it to Ghost. T could be, transmogrifier, thingy, whatever. I think we actually have some names on the website. So basically, it's kind of the same situation, very similar to Facebook's, except what we figured out in that meeting that we had back in February was, you know what? We don't need to put things into a changelog table. MySQL already has that. The binary logs, which are used for replication, keeps track of all the inserts, deletes, updates. So everything there should be good to go. And that's basically what we have here. Let's see here. I don't have my next slide thing, so let's see here. Okay, so yeah, basically, so Ghost basically connects to the master and iterates through the rows. And so basically what it's doing, let's see, I think I have a better, yeah, so basically what it's doing is it's going through, let's see here. Maybe I should have taken that microphone. Anyhow, so basically what it's doing is with the yellow lines here, it is basically Ghost is connecting to the master and saying, okay, I need to do an insert into this Ghost table, this secondary table, and just iterates through. Then in addition to that, Ghost is connecting to the replica and pretending like it's just a replica, and it's going to get all the information about all the updates, inserts, and deletes for the table. Now, the binary log doesn't just connect for one table, it's for all of them. So Ghost basically says, oh, this is not what I need, it just skips it. It only looks for the table that it's modifying. So that's how it goes about there. Now, there are kind of three different models here of what you can do. The first one is how we run it in production. Basically what you're doing is you're connecting to a replica. And in the case of, for us, that replica is still taking reads just like any other application. But you can also use a replica that is not being used to even, to basically cause, to prevent any disturbance of read replicas. And basically it's getting all the information from there, and then it's writing up to the master, which ends up replicating to your replicas, and then eventually cuts over and does the change similar to the other tools. Another scenario is you could connect directly to the master. We don't do that because there's different bin log formats for replication, and Ghost requires row-based replication, and basically the reason for that is that it's easier to parse through. If you were to use statement-based replication, which is another mode for MySQL, is you'd have to parse through every single insert and update and every weird iteration and possibility, and it would be really difficult. So row-based replication is how we went, and it worked out really well. Now, the third one here is how we test and make sure that this works, that this is it was how we decided this is the tool that we want to use, this is going to work for us. And basically what happens here, let's see, do I have that on the next slide? Yes, testing. Yeah, basically what it does is it goes through this entire process, but it only writes to the replica. So in some cases, you would want this, well, in most cases actually, you would want this to have like a dedicated server for this, or dedicated connection for MySQL. We use AWS for us, and it works out really well for us. Basically what it does is it goes through, it does the alter table on the replica only. It makes a table, it's like underscore table name underscore gho or something like that. and it will go through, and it'll go through the entire process of copying all the data, doing the rename, but then it will quickly rename everything back and then stop replication. At that point, what you can do is you can look at the table to kind of build trust. And basically what you would do is you would, at that point you could do a select star, get, of the two tables, make sure the count's the same, do checksums, do whatever you need to do to verify that, okay, these two tables, they ran through this process, and what changed is what should have changed. In our particular case, we have three AWS boxes that are constantly running on our production servers that just goes through every single table and just does an arbitrary alter that doesn't make a change, but just goes through the process of saying that, okay, I'm going to do this alter. The alter copies the table. The alter does nothing, and it just copies all the data, and then at the end it breaks out and verifies that everything looks good. If there's a problem, then we would end up getting an alert and having to look into it. Another thing that we have the ability to do is throttle. Now, I was mentioning the PT Online schema change. It will stop on replication lag. That's the same thing that we have. Another thing is it can stop on threads running. So if basically the performance of your master database starts feeling the effects of having to write to the second table, it's going to slow down. It's going to say, hey, I'm stopping for a second here. I'll check back in a second, and we'll keep going then. In addition to that, and the last two bullet points here are in addition to what PT Online schema change is you can write an arbitrary query for the tool to look for, and if it doesn't return 0, then it throttles. So if there's some other mechanism that you want to use that's in the database to determine if you want to throttle this or not, you can. And then the last option is just a flag file. Basically, you can put a file in place that says, hey, I don't want to do anything right now. And where this comes in to be really helpful is, let's say someone comes to you and says, hey man, databases are running like crap, but you haven't gotten any alerts, you don't see anything that is concerning, but you're like, okay, well I am running a migration, let's go ahead and stop that for right now. Now with PT Online schema change or the other tools, you just have to break out. You'd lose anything that happened previous to that, you'd have to start over. With this tool, what we can do is we can throttle it, and basically the writes to the secondary table are done. They stop. You don't, any impact that was caused by the migration is no longer there. Now there is one table that we keep track of metadata, and it writes about once a second. So if you're hitting the point where one more query is a problem, then yeah, absolutely, you should probably break out and go from there. The other thing that we added for Ghost that was really useful is a cutover flag. One of the things that when we were doing migrations before, we would want to time things in such a way that the migration would finish when someone was there. Not that there was a huge concern about the cutover being a problem, but people like to be around, especially if you're removing a column or something, or the column that you're adding is basically waiting on some functionality for your application. And so what this cutover flag allows you to do is say, I don't want to cut over until someone's here, until someone says, you know what, it's time that we do this change right now. And so basically what you can do is you can set this flag to say, don't cut over until I'm there, and then it'll wait. And so once the copy is complete, it'll just say, okay, well, I'm done, but I'm going to just keep monitoring the binary logs, and every time there's a change, I'll go ahead and keep things up to date. But until you say go, it doesn't go. And so that's nice. Now the great thing about this, and all the options and other options that I hadn't mentioned, is there's a way to do all this interactively. So basically, another problem you can run into when you're doing an online schema change is you can set, threads running or threads connected or whatever, and you're too aggressive, or you have the max lag to be 2 seconds, and that's just too long. The application just doesn't like it when things are that far behind. Well, with PT Online schema change, you would end up having to break out, start over. With Ghost, what we can do is there's files that you can use to update, or there's a TCP connection that you can use. So you can, in our case, we use ChatOps to say, you know what, max lag was 2 seconds. Let's change that to a half second. And within a second, it says, okay, hey, now I'm going to use a half second, and it's going to continue to run. Like mentioned on here, the other things that you can do, there's a nice function that basically says, hey, every time you iterate through a chunk of data, it's going to wait a little time before it starts the next one. We initially had that in place before we were able to do lag at sub-second levels. Originally, we could only do lag 1 second or 2 seconds. Now that we have the milliseconds, we've been able to lower that, and then we haven't had to use nice so far since then. But there are other possibilities that people would need. Like I mentioned before, with the throttling, you can throttle. You can just run a command to say throttle or unthrottle, and that will work. And then the cutover, like I mentioned just previously, that's a command or a file, either way. Let's see here. So that's kind of where Ghost is right now, but there's some more things that we want to be able to do with it, and so I'll go over a couple of those. One of the things is that right now Ghost is just used for altering tables. However, it could actually be used for copying tables to another location. So in my example here, maybe you have your data sharded by schema, and you want to copy some data from schema 1 to schema 2. Let's say you have customers 1, 2, and 3 on the first schema, and you want to move customer 3 over to schema 2. Ghost should be able to do this in such a way that it's copying the data over to schema 2, and then just be sitting in that state where it's not cutting over until the application developer says, you know what, we're ready for this. Cut over. We'll do whatever you need. Or maybe there's some other table that has the mapping, and that would be changed there. So then. In the same kind of lines, the other thing that would be great is maybe you want to copy your data from one replica set to another. So if you have things sharded by replica sets, you could just move over your table, move over your data that way, which would be another interesting work case. The other thing I didn't mention is that right now there is a way that Ghost will break out, but there's a critical load, and so basically what will happen is if the max threads running is, let's say, 1,000 or whatever, Ghost will say, that's too much. Even throttling, I'm not even comfortable with just throttling. I'm going to break out. So it'll exit out of the program. Unfortunately, that situation means that you have to start over. Well, we have that change table that keeps track of what's going on. We should be able to just start Ghost back up and say, oh, hey, this is where I was last time. Let me start back over. Last thing I wanted to mention is Ghost is open source. We open sourced it. Basically, what happened is after our meeting in February, we started working on it, and we decided. We started working on it, got it, into a semi-good spot. We invited a couple people to the repo and said, hey, do you have any feedback? And they helped out. Once we got it running on our own systems for about a couple weeks, we open sourced it and allowed, contributions from the outside. because we don't hit every aspect of what someone might need. An example is we don't use RDS in our production servers, but there was someone who did, and they wanted to use RDS, and they sent us a pull request, and it was spectacular. And now we have RDS, the ability to do RDS. So we are definitely, we definitely want any help that anyone would want to use this. Like I mentioned here below, there are limitations, and we want to get rid of those limitations, and we want help with everybody doing that. So let's see, and that is it. Okay. So I'm not so good with the vision, so if anyone has questions.
When you are doing control, there still can be some writes on the original table.
Mm-hmm.
What you do?
Basically, there's a mechanism to, there's basically a trick that we did that allows us to gosh, I can't remember the exact specifics, and I think it might be in the documentation of how we basically set up a couple of connections. We set up a lock, and then we set up the rename tables, and then once we release, the rename table basically ends up to the top of the queue, and as soon as you release that lock, the tables get renamed first, and then any writes that happen after that will be to the new table.
Do you use referential integrity?
That is actually one of the features that is not working yet. That is on our list of things that we want to work on, but we don't have any tables that use foreign keys right now.
So this is now the third generation of somebody fixing one of those nuances
Yeah.
in MySQL that makes it not PostgreSQL or SQL Server.
Sure.
You feed them I noticed you're using their binary log, which is so you're actually using functionality. You've taken the next step, which you're leveraging functionality that MySQL is providing. Do you have any sense as to whether or not you maybe provided a more clear roadmap to those folks to say, oh, no, you just go down this way and turn some of this into C and add it to the DLL and off we go?
I would love them to do that. That would be spectacular.
No, they are open source. You can pull it.
Yeah, no, yeah, absolutely. It's there's actually when I upload the slides, I'll actually have a couple links, because there was actually there was a conversation. Shlomi Noach was the person who actually originally wrote the majority of Ghost. And when we had a blog post about it, there was someone that says, well, why not Postgres? And which is pretty typical on Hacker News, actually. But and so we went through, and they're all databases have their limitations and problems. And I agree that this the fact that we are doing a third iteration of or third generation of this kind of thing, it's a little bit crazy. But yeah, I certainly hope that MySQL will look at this and say, hey, maybe we can leverage this. That'd be pretty awesome.
Why not Postgres?
Why not Postgres? Well, first off, I can only speak for a very limited amount of Postgres knowledge. So the first thing I would say is we're already using MySQL. The complete upheaval of that would be probably difficult. I have, like I said, very limited experience, but it seems like Postgres has had is not as operationally lenient. So there are some settings that you just have to restart the entire cluster for. Granted, there are some situations where you have to restart the server for MySQL also, but in the cases that I know of, you can just kind of basically do that on all the replicas, put in a new master, and then go from there. I do actually think that there are some things that we are looking at for Postgres, but not for what we have right now.
What language is Ghost, and what library did you use to parse the binary logs?
Ghost is written in Go, and I don't know on the binary logs.
Parsing the binary log or doing triggers only gives you updates since you started doing that. How do you copy the original table data as well?
The original table data, basically what you're doing is you're going through, and it's doing what is it? Insert into new table, select star from old table, and I believe there's inside that query, if it finds a row, it just ignores that row. So the rows that are getting updated from the binary log will be the latest information.
I guess that the previous conversation inspired a question from 12 years ago me, where when I was working with MySQL as the primary data source for the entire company and trying to stream data out of it, normalize it on the way. And it seems like that's actually a valid use case for migrating off of MySQL too, right? Like being able to real-time, well, almost real-time stream your data out of MySQL into another store and slowly migrate applications into that. And all these things they have to set up the streaming service. How hard would that be to kind of bastardize Ghost to do?
I don't think it would be terribly difficult to get Ghost to basically send things out in a predetermined format that could be put somewhere else. I think that's getting into, there's something called Tungsten Replicator that does do that, where it basically streams MySQL to Oracle, to SQL Server, to several different things. So I don't know that we would probably focus on that, but if someone wanted to work on it, we'd probably listen.
By the way, speaking of Postgres, couple of months ago there was a huge post from Krouper development team about how they went from Postgres to MySQL because of replication problem. It was exactly because of the versioning mechanism and shipping logs and all that stuff. And how Postgres didn't work for them, while my cluster of MySQL worked.
Yeah.
So this is one more, but in what sense, I want to ask you, I didn't get it. In what sense this problem is kind of solved in PostgreSQL or in MySQL? I'm mostly where are on MySQL, and we're kind of facing the same problem, how to apply big migration changes to big databases, and how to do it smoothly with minimum downtime. We have hours of downtime currently. And I don't see how it's different or how it's solved there. Maybe Postgres, I don't know much, because I didn't work with it. But on MySQL, it's some stuff.
That's good to know.
Yeah, well, I think, there are limitations on every database. There are good use cases for every single thing. There's a great use case for Postgres. There's great use cases for Dynamite that we heard about earlier. There's great use cases for everything. It's the trick is always which one is the most right for the application that we're writing. But yeah, so I think when you're having that conversation at the after thing, I'd love to hear it too. So.
Well, I liked your comment that you prefer to do it overnight. What is night to GitHub?
Oh yeah, no, absolutely. GitHub is we have people all over the world. Yeah, overnight is no longer really a thing.
SQL Server has changed data capture, which leverages reading its own logs to push changes to a table that you can read later, which could help.
All right, thank you.